now that we've worked out the examples, let's take a look at the even problems. And the odds, the answers to the odd questions are online. So let's take a look at the evens. And same thing, just like what we talked about in the examples, let's start with an inventory. So we have calcium and we have oxygen. And that's the only thing we have on that side, calcium and oxygen. Let's get an inventory, so we have 1 calcium, 2 oxygen. We have 1 calcium, 1 oxygen. Hopefully that one's not too difficult to see here. So let's see, we have 2 here, so that means we need 2 there, which gives me 2 oxygen, and it also changes my calcium to 2. So put a 2 there, and we're balanced. So again, when looking at these, we want whole number coefficients. If you don't have a value here, assume it to be 1, unless you're just dying to put a 1 there. You may. I won't. But I won't count it wrong at this point in the game if you do put a 1 there. Let's look at number 4. Same thing, start off with your inventory. So we have 1 potassium. We have a total of 2 oxygen. Oxygen. Let's do it in the right order here. So we have potassium. Oh no, I was right. So we have oxygen and hydrogen. Same thing over here, potassium, oxygen, and hydrogen. And then let's write down the values that we have. We have 2 potassium, we have 2 oxygen, and we have 2 hydrogen. We have 1 potassium, 1 oxygen, 1 hydrogen. And again, when those values are the same, we're good. So this one looks extremely difficult, especially once you do that. If you go ahead and put a 2 there, I think that takes care of everybody. 2, 2, and 2. Sometimes they're just that nice and easy. Okay. All right. Number 6. Here's one of our combustion reactions. So again, start off with your carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. We have 2 carbons. We have a total of 6 hydrogen. We have 2 oxygen on this side. Over here we have 1, 2, and 3 oxygen. So 2 hydrogen and the 3 oxygen. We have 2 there plus the 1. Okay. Again, like I said in the examples, make sure or try to make that an even coefficient. Try to balance the water first, and of course, save the oxygen for absolute last. Okay? So those are really helpful tricks. So when looking at the hydrogen, they're not the same. So let's go ahead. I have 6 hydrogen over here, so I need 6 over here. If I put a 3 there, that's not a good number. We don't want a 3 there. We want an even version of 3, so double it. Make it a 6. Okay? So make it an even number. Now let's write down how many we have. So 6 times 2 is 12. And then let's balance out the oxygen. So we have 6 of those plus 2 more. So total 8 there. Okay, so now that means we need to fix the hydrogen on this side. So we have 12 over there. We need to put a 2 there, which gives me 12 hydrogen. And changes the carbons to 4. So now we can balance our carbons, putting a 4 here. So now I've got 4 carbons, 4 times 2 is 8 oxygen, plus 6 times 1, so 8 and 6 is 14. So if I want to get 14 oxygens over here, notice I'm saving this for last. Take 14 divided by 2, and that gives me a 7. So now I've got 14 oxygens on both sides. Ask yourself, can these be reduced down any further or simplified? And I have an odd and an even. I cannot, so this is as low as she goes. Another combustion reaction. You're going to learn to love these. So we have carbon, hydrogen, and oxygen. Again, carbon, hydrogen, and oxygen. So over here we have 8 hydrogen. Here we have 18 hydrogen. 8 carbon, 18 hydrogen, and 2 oxygen. And here we have 1, 2, 3. You'll just get fast at doing that. All right, so again, try to balance the hydrogen first. So we have 18 over here. We need 18 on this side. So if I put a 9 there, that gives me 18. Not a good number. We want an even version. So multiply that 9 by 2. So now we have 18. So 18 times 2 is 36. And let's fix our oxygen. So 18 times 1 plus 2 is 20. Fix your hydrogen if it's not good. So we need to double that. Now that gives me 36 hydrogen and 16 carbon. So now I need to fix my carbons. 16 there. All right, so now I've got 16 times 2, which is 32 plus 18. 32 and 18, what is that? 50, good, okay. So now I've got 50 oxygen on this side. Carbon looks good, hydrogen looks good. I need 50 oxygen. So to get 50 oxygen, I'm going to take 50 divided by 2, because I have 2 oxygens there, and that gives me a 25. Real quickly check, can that be simplified or reduced? It cannot, so that is our coefficients here. And again, they must be whole numbers, you can't have fractions. Okay. Here's a fun one. Alright, let's see. Yeah, let's go ahead and do an inventory for this. So we have sodium, we have hydrogen, we have carbon, we have oxygen, so sodium, hydrogen, carbon, oxygen. On this side, we have sodium, I'm going to put it in the same order, hydrogen, carbon, and oxygen. I don't even need to check because I know that those are all there, even though they appear more than once. Okay. So let's get a number here. We have 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygen. So that's on the left side. On this side, we have 2 sodium, we have 2 hydrogen, yep. We have 1 carbon plus a second carbon, so we have 2. The oxygen, we have 3, 4, 5, 6. So we have 6 total oxygen. Okay. Again, when those numbers are the same, you're balanced. They are not. So try to save the hydrogen and oxygen for last. So even though it's listed second, we'll jump to the carbon before we try to do the hydrogen and oxygen. So sodium, looks like we need 2 over here. So that changes my sodium count to that. I now have 2 hydrogen. My carbon, I now have 2. And my oxygen, I now have 6. And, well, looky there. We are balanced. And sometimes it's just that easy by just balancing one value. And when these numbers are the same, you're balanced. All right, number 12. Notice again, like I said in the examples, I'll do it the long way. Okay, so let's go ahead and put our magnesium. If you remember for the examples, nitrate, NO3. Okay, so I'll let you think about that. If you didn't watch the examples, then you'll have to learn about it later on. Silver, nitrogen, scoot this down a little bit. Oxygen, I think that's everybody, magnesium, silver, nitrogen, oxygen, got it. Same order, magnesium, silver, nitrogen, and oxygen. Let's write down how many we have. Looks like we have 1 magnesium, 1 silver, 1 nitrogen, and 3 oxygen. Here we have 1 magnesium, silver we have 1, nitrogen we have 2, so 1 times 2 is 2, and oxygen we have 3 times 2, which is 6. So, okay. Magnesium looks good, silver looks good, doesn't mean it's going to stay that way. Nitrogen, let's fix that guy. Let's put a 2 there, so now we've got 2 nitrogen, 2 silver, and oxygen we now have 3 times 2, which is 6. Okay. So magnesium looks good. Silver we need to fix, so put a 2 here. and we are finished. And again, that's a 1, that's a 1, so these can't be reduced down or simplified. Okay. Number 14, they just get more fun. Let's write down the inventory. So we have, again, if you remember from the video earlier, phosphate, and our non-metal, here's chlorine, so you can do that. Actually, let me show it to you since you're watching. So here's your phosphate, and phosphate means PO4, doesn't change, it's a polyatomic, one of your polyatomics. And here's another one, but here we have in parentheses 2, so again, when we look at that phosphate, we actually have a total of 2 of those, and here we have a total of 1. Okay, so we have 1 phosphate here, 1 phosphate over there. So if you have a polyatomic that doesn't change from this side to this side, hey, use it, treat it like an element. Now we could not do that over here because the carbonate, yeah, it was a carbonate here, but it also changed into a carbon dioxide, so you don't want to try that. So if that doesn't make sense, that's fine. All right, so if you want to do the long inventory method that I showed in the previous, go ahead and do that. I'm going to show you a quicker way here. So sodium and phosphate, I'm going to keep them together. Barium and chlorine. Now, notice that the chlorine is not a polyatomic. I am not bringing that subscript over. Don't do it. Okay, it's an element. Polyatomics, you can leave it alone as is. I'm going to write this over here the same. So I have sodium, phosphate, barium, and chlorine. Okay, so let's get some numbers here. The sodium, I have 3 of those. Phosphate, I have 1. Notice I don't have a parenthesis around it like I do on that one. So there's 1 phosphate. Barium, there's 1. And chlorine, there are 2. Over here, I have 1 sodium. How many phosphates? In parentheses, I have 2. Barium, I have 3. And chlorine, I have 1. Okay. All right, well, looks like there's no hydrogen or oxygen, so we don't have to worry about that, even though, yeah, there's oxygen in there, but it's part of a poly. So sodium, we have 3, so we need 3 sodiums over here. Let's not do that yet. Let's go to the phosphate. Okay, let's do that one first. Now, again, let's do it. Let's put a 3 here. But you make sure you have your eraser and make sure you're using a pencil. We're going to change that. Okay, so that means that we have 3 sodiums and now we have 3 chlorines. Okay, so that looks good. So our sodiums look good. Phosphate, we have 1 on this side, but we have 2 on this side, which means that we need 2 there. That's why we're going to have to change that sodium. So now my phosphates are PO4. I have 2 of those, and my sodiums, I now have 6. So let's fix our sodium. So get rid of that guy. If I need 6 of those, that means I'm going to have a 6 there, and that changes my chlorine to 6. Okay. All right, so my sodiums look good. My phosphates look good, so let's fix the barium. I have 3 here. I have 1 there, so that means I need a 3 there. So there's 3 of those. And then chlorine, 3 times 2 is 6. I believe I'm done. Okay. So again, when we're balancing the chemical equations, make sure you have the same number of atoms on both sides, or same number of polyatomics on both sides. Okay. All right, the last one, number 16. Here we do not have polyatomics that remain the same, so that is a long way of doing this one. So we've got sodium, we have carbon, we have oxygen, we have hydrogen, and we have chlorine, and that's it for that side. Let's keep them in the same order, just for order's sake. Sodium, carbon, oxygen, hydrogen, and chlorine. And again, even though it's listed second, third, and fourth, we're not going to balance them in that order, but we'll get to that here in a second. So sodium, we have 2, carbon, we have 1, oxygen, we have 3, hydrogen, we have 1, chlorine, we have 1. Okay. Sodium, I have 1, carbon, I have 1, oxygen, I have 3, hydrogen, I have 2, Chlorine, I have 1. Okay. So my numbers don't look the same there, so let's start with the sodium. I have 2 over here, so let's put a 2 there. So that changes my sodium and my chlorine. Okay. Carbon looks good. Let's skip the oxygen, hydrogen, come down to chlorine. Again, try to save oxygen and hydrogen last if you can. Okay, trust me on this. So chlorine, we have 1, which means that we need 2. So if I put a 2 there, then that means I change my hydrogen to 2. And we are finished. So it looks good there. And again, when working these types of problems out, and hopefully you're attempting these before you watch it, but the thing about this is it's not difficult if you stay organized, remember some of the tricks that I'm showing you, and just make sure you're using a pencil. Hope this video was helpful.